So let us start with this introductory lecture which covers the introduction and the basics of Arduino. So as part of today's lecture, I plan on first discussing what is Arduino. Then I would discuss a few basics of the Arduino board. Then I would spend some time discussing about the types of inputs and outputs that the Arduino board has. Then we would spend some time understanding what are the steps to program an Arduino board in a small amount of detail. And then I would spend some time showing you how to go step by step to program an Arduino board. Again, I would not go through the program, we would just go through the steps, but we would go through the different parts of the program in subsequent lectures. So what is Arduino? Let's break this up. It is a simple to use open source. Open source means that the design that we have is open to all. You can look up on the internet and find out the design for this Arduino board, and a lot of programs, a lot of projects are available. Obviously, this is an electronic hardware. So Arduino is a simple to use open source electronic hardware that mainly contains an electronic chip, which you see here. This electronic chip is called a microcontroller. From now on, I will be calling this a mu-C. This is the Greek letter mu. And after the microcontroller, it has some standardized hardware like a USB interface chip, a USB interface, some I/O ports, and these connections that I just showed are simplified and they are standardized so that life becomes simple for users like you and I, and we can interface a lot of standardized hardware to this. So to summarize this point, Arduino is a very simple to use, as you'll see as a part of this course, that it's an open source hardware platform that mainly contains a microcontroller chip, some standardized hardware, and connections that are scalable and can be used by everybody. That said, let's explore this Arduino board in a little more detail. So if you look at this Arduino board carefully, there is a microcontroller or a mu-C which acts as the brains behind the system. It does most of the thinking, or in more technical terms, the processing. And for the microcontroller to communicate with the outside world, the Arduino board gives you 14 digital pins which can be configured as input or output. So there are 14 digital pins. There are 6 analog pins. And these are purely input, whereas the digital pins are both input and output. That said, these digital pins, some of them can be used for some specific functionality, like a serial interface, which we will be discussing in a future lecture. Or it could also be used to generate something called as a PWM signal, which is called as a pulse width modulation. Again, I will be discussing that as part of a future lecture. So to summarize this, you have 14 digital input-output pins. Basically, a digital signal can take values 1 or 0. That is where 0 typically stands for 0 volts, and 1 on this Arduino board can be selected between 3.3 volts or 5 volts. The analog pins are purely input. That said, your board also has a USB connector which helps you connect to a PC, from where you can download the program onto the Arduino board. Once you download the program to the Arduino board, after that, if you choose not to connect it to the PC, then you can power the Arduino board from an external power connector using this. The board under discussion is a typical Arduino Uno board, which is the most basic board. There are a few other boards, but the functionality is more or less the same of the advanced boards as well. Once you understand this basic board, I'm sure you will be able to use the more advanced boards that are there. And again, we will be discussing that as a part of our future lectures. You have some standardized chips as well. You have, as I said, the USB chip. You have some standard components, resistors, capacitors. So this was the Arduino board and understanding a few details of it. Just to summarize, the microcontroller, or the MUSI, the brains of the system. The I/O pins are like the hands and legs, as you can interface. You can also, for certain power supplies, you can take or you can give VDD or ground connections. Here, VDD is typically power supply. So you can take that from the board. Ground, again, you can take that from the board. So I hope that this part of the lecture is clear. So that said, the questions that might be coming to your head are that what can an Arduino board do? Well, an Arduino board can do a lot of things. It can help you interface with a motor. It can help you interface with LEDs. It can help you interface with slightly more advanced concepts like resistive touch. That is, if you want to interface and take a touch input from your finger, you can actually interface that with an Arduino board. You can also use character displays. Say you want to display hello world in caps, or you want to display Aduvance. If you want to go slightly more advanced, you can decide to make a robot or a car bot with 4 motors, and you can control that using an Arduino. You can do even more advanced concepts such as Zigbee, RFID, and a lot more. So there is a lot that Arduino can do. As a part of this course, we will be covering a few of the concepts. A few of the other concepts would be a part of an advanced course that we will see in future lectures. So, that said, let's understand and spend a few moments understanding the brain of the Arduino, that is the microcontroller. So, the microcontroller has a few components inside it. You have the processing component, you have some memory, you have a few what we call as analog to digital converters, or ADC. ADC stands for analog to digital converters. As you know that this Arduino has a microcontroller which is manufactured by Atmel. The analog inputs would be directly fed to these ADCs. So if you remember in 2 slides ago, we had these analog pins which would then go and interface directly onto the ADCs on the chip, which would then feed on to the processing element based on the program that is stored in my memory. So, that said, the analog signals would then convert the analog cut from so that said. So that said, the analog to digital converter converts the analog signal into a pattern of signals which are more zeros and ones that is well understood by my microcontroller. So that takes me on to my next point, that is, how do I talk to this microcontroller? The microcontroller, as we know, speaks the language of digital, that is zeros and ones. It understands something called as an instruction set, or a set of fixed digital instructions. For example, add, subtract, and so on, move. So these instructions in memory are stored in something called as a hexadecimal format, or a hex format, which is a string of zeros and ones in a particular format. That said, if I say that you need to program the microcontroller using a strings of zeros and ones, then how does Arduino become so simple? Because if I say it's simple and on the other side I say that you need to know the instruction set, then that's a contradiction, right? They are 2 sides apart. Well, the answer to that is, if I want to speak a language A and the opposite person understands only language B, then I need somebody in between called as a translator. Similarly, for an Arduino board, you write a program which is in a higher level language which is very similar to English, with a little bit of logic to it, and then you run it through the Arduino application or program that has inside it something called as a compiler. A compiler, in a very literal sense, can be called as a translator. So what does this translator do? The translator takes this so-called pseudo-English program, understands it, and then converts it into a more familiar form called as a hex file. After that, what happens is I take that hex file and then plant this hex file into the memory of my microcontroller. How does this help me? I then bypass the need for the knowledge of the instruction set, and it makes my life much more simpler by me just wanting to write a program which is in a higher level language. So that makes my interface really simple. So to summarize that, to program the microcontroller, I need to first understand something called as an instruction set, which is a little bit complex. So to make it simple, we have somebody called as a compiler who helps us translate this higher level language into something called as a hex file, who contains words or statements that actually my microcontroller understands. So that said, let's understand how does Arduino work. Here I have my Mr. PC, or my personal computer, or could be my laptop. I run something called as an Arduino program or an Arduino application, where I can write a program in a higher level language which is partly English and partly taken from a technical programming language called as C. It is very less on C, it is more on the English side, so don't worry. I write my program, after which I do a step called as compile, which is, I can use the word translate. After I compile the program, it automatically generates the hex file or the hexadecimal file, and then I program the Arduino board or configure via this USB connector, and it then goes and sits onto the memory component inside my microcontroller. Now, based on what the program is, or the features or the specifications, the brains of my system will actually function. For example, if I'm saying that I would like to glow these LEDs, then this microcontroller, and also let me assume that these LEDs are connected to pins 11, 12 and 13. So then this microcontroller, what it would do, and okay, let me add another application saying that first this LED should glow, then this one, and we should go back in order. So basically what this microcontroller would then do is, depending on how these LEDs are configured, which we would see in the next lecture, I would then glow this LED first, then this by giving a signal either 0 or 1, again as I said, depending on which signal I'm doing or what configuration. I would then go serially here. Again, that would depend on the features and specifications of your program. So to summarize this step again, that first I would start the Arduino application, then write the program, then compile or translate, generate the hex file, program my board, and then watch. Okay, so I hope that this introduction was clear. To summarize this part of the introduction, let's just go over this again. We first understood what was Arduino. It was a simple to use open source platform with a microcontroller and standardized hardware. Then we understood the different components of the Arduino, the microcontroller, the digital I/O pins. the analog input pins. Mind you, the analog is only input, just for reference again. I would have USB connectors, power connectors, and then I discussed what an Arduino can do. As we see, there are a lot of things, and as part of this course, we will be seeing a lot of things. And then we spent some time discussing about the microcontroller and why do we need the compiler. And then I spent some time discussing about the usage of an Arduino, how we write an Arduino application and go through the process. So now let's actually see this process at work.